Welcome to solverfy.
In this problem, we are asked to find the indicators of the following titrations. In part A, we know that this is a titration between a weak base and a strong acid. And in a titration between a weak base and a strong acid, the equivalence point will have a pH that is greater than 7. We will need to construct an ice table. We will first write out our chemical equation for this reaction. Since both the base and acid are solutions in 1 liter, our number of moles would be 0.5 moles for both the base and the acid. So this is where we will start off. And at the equivalence point, the number of moles for the acid and the number of moles for the base should be equal to each other. Next, we will minus both sides by 0.5 moles, because this is the number of moles that will go under reaction. And we will find our final number of moles for this reaction. Next, we will need to find the molarity of CH3,2NH2. Now, because for the base and acid, they both are constituted of 1 liter. So in addition, or the sum of the acid and the base will give us 2 liters. So to solve for the molarity, we will have 0.5 moles over 2 liters, which gives us 0.25 molars. Next, we will do another ice table for the strong acid. In this, we will solve for the concentration of H3O plus to solve for our pH value, which will help us indicate what our indicator is. We will disregard our water, and we know we have 0.25 molarity of CH3,2NH2 plus. Our change is X, which is our unknown, and this is our final change of molarity. We know that our Ka value is given here. That is equivalent to x squared over 0.25 minus x, where the products are over the reactants, which gives us our Ka value. From this, we can put this equation in our calculator and solve for our value for x. Our x value is also equal to the concentration of H3O plus, which is this value. Next, we can solve for our pH value, which is negative log of H3O plus, and our pH is 5.686. As we look at the chart in our textbook, this will indicate that our indicator is methyl red. Next, in part B, we are given 0.2 molars of KOH and 0.2 molars of HNO3. We know that KOH is a strong base and HNO3 is a strong acid. In a titration between a strong base and a strong acid, our equivalence point will have a pH equals to 7. So following our chart, this will tell us that our indicator for this titration is bromothymol blue.